Okay, so U-substitution we have already learned about, but when we were doing U-substitution before, we were doing them on indefinite integrals. In other words, integrals that did not have lower and upper bounds of integration. So now we're going to be doing integrals that have U-substitution that also include an upper and lower bound of integration. So here we go. Okay, so looking at our first example, what we're going to do, we're going to need to find the antiderivative and then substitute our values into the antiderivative. So in order to find the antiderivative, this is going to require a U-substitution. So if we take a look at what we've got here, our U is going to equal the inside function, that's x squared plus 1. That's going to make our du equal to 2x dx. And we have the x dx, we just need the 2. So if I'm going to put a 2 into my function, then I'm going to need to put a 1/2 also. So what that's going to mean for us is that this is going to become the integral of u to the third power, du, and then I'm going to have a 1/2 outside of it. And then we also need to worry about these numbers right here. So if we look at the 0 and the 1, the 0 and the 1 right there are not u values, they are x values. So what we can do here actually is we can convert our x's into u's by using this equation that we've already established right here. So the actual values that are going to go right here and right here are going to be u values, not x values. So if we take a look at, if we look at an x value of 1, then that's going to give me 1 squared, I'm sorry, an x value of 0. That's going to give me my u value of 0 squared plus 1, or in other words 1. So my lower limit of integration is now going to be a 1 instead of a 0. If x is equal to 1 for our upper limit of integration, that's going to lead us to a 1 squared plus 1, which is actually going to equal 2, and so that's going to give me my new limit of integration up here as a 2. So we can work this problem now in terms of u, and we do not need to worry about x's anymore in the problem. Normally when we did u-substitution when indefinite integrals, when we did not have our upper and lower limits of integration, we had to change back to x's at the end of the problem. But here in this case, since our answer is just a number, it doesn't matter, and we can go ahead and simply use the values of u, the 1 and the 2, to work with instead of the 0 and the 1 by switching them back to x's. So we're just going to leave everything in terms of u, which actually makes the integration a lot easier, because we're going to have our 1/2 that we already had out there. The antiderivative of u to the third is going to give me a u to the fourth with a 1/4, remembering to do the reciprocal. And then we are going to substitute in a 2 and a 1 into that. And so that's going to give me a 1/8 really. And then what I'm going to get is I'm going to get 2 to the fourth and I'm going to get 1 to the fourth to plug in. So I'm going to get a 1/2 times 1/4 is really going to be 1/8. And then I'm going to get my u to the fourth, 2 to the fourth, which is going to be 16. And I'm going to get my 1/8 u to the fourth with a 1, which is just going to stay 1. So when we simplify that out, 2 to the fourth is 16. 16 times 1/8 is going to be 2. And then 1 to the fourth is 1 times 1/8 is, of course, 1/8. So I'm going to get 2 minus 1/8. If I wanted to go ahead and combine that together and get a common denominator, that's going to turn my 2 into 16/8. and give me a total of 15 over 8 as my end result. So no x's need to come back into the problem because we switched all of our x's over to u's, and since we're getting a numerical answer at the end, not an x answer at the end, we do not need to switch back to x's to finish the problem. Okay, similar concept here for example 2. Example 2, we are dealing with another U-substitution. So we're going to make our u value equal to the inside function, which is going to be my x cubed plus 1, and then my du, therefore, is going to be 3x squared dx, which we have the x squared and the dx. We don't have a 3, so we're going to need to input a 3, which means we're also going to need to input a 1/3. Okay, so when we do our rewrite, we are going to get our 1/3 on the outside, integral. It's going to be the square root of u, or in other words, u to the 1/2 power, du. And then for our upper and lower limits of integration, we are going to get, well, if u equals to x cubed plus 1, so 1 cubed plus 1 is equal to 2. And 2 cubed plus 1 is now equal to 9. So we are going to have a lower limit of 2 and an upper limit of 9 now, using our u limits instead of our x limits. So now we can go ahead and do the antiderivative. So we're going to have a 1/3. We are going to get our u is going to get now added 1 to the exponent. That's going to be a 3 over 2 power. We're going to multiply that by the reciprocal. That's 2 over 3. And then our 2 and our 9 are our lower and upper limits of integration. So if we simplify that a little bit, that's going to cause this fraction up front to become a 2/9, and then u to the 3/2, the 9, and a 2. So in order to simplify that out, we are going to substitute in a 9 into the function. That's 2/9, and then 9 to the 3/2 power, and then we're going to subtract 2/9 times 2 to the 3/2 power. The first calculation is going to be much easier because 3/2 power, remember that means that we have a square root and a cubed. Well, the square root works, so the square root of 9 is 3. 3 cubed is 27. So this is going to turn into 2/9 times 27 minus 2/9 times, and then the square root of 2 cubed is going to be our result right there. We can clean that up a little bit. By, well, let's see, 27 divided by 9 is 3, so 2 times 3 is going to be a 6. That whole thing's going to become a 6 right there, minus, and then this right here is going to become 2/9, and then the square root of 2 cubed actually is going to simplify into 2 root 2. And then if I clean that up just a little bit more, we can get 6 minus 4 root 2 over 9 if we wanted to put it all together. So, big picture here is that we are still doing our U-substitution, but one of the big differences in the U-substitution that we're looking at is going to be the switching of the lower and upper limits of integration using our U equation right there in order to change our x's to u's. Then we do not need to change back to x's, and we can just perform our calculation down here just using the U value, lower and upper limits of integration. Okay, so this is the last video for me. Please see Miss Maroon in C4 if you guys have any tutoring concerns. Keep in mind, as listed on the board, that there is going to be a quiz next week. So I'll be seeing you guys on Tuesday. Tomorrow, or Friday rather, you will be receiving a study guide for the quiz, which will be kind of a review of what we did this week. So, good luck on that. Once again, see Miss Maroon in room C4 if you guys have any further questions. And I'm looking forward to seeing you guys next Tuesday.